So I want to welcome you guys to the 4th International SLC13A5 Deficiency Research Roundtable. It's always a title that rolls off the tongue. This roundtable is different from any of our past roundtables. It's our first virtual conference. It is also our first conference held in the midst of a pandemic. I know that you are all feeling extra anxious and overwhelmed, and many of you are joining us from your homes. You're juggling children whose schools have closed, clinicians are worked to the bone, and some of you researchers have been forced to close down your labs temporarily. None of this is lost on me, and so I say from the bottom of my heart, thank you. Thank you for making the effort to be here today. Thank you to our speakers who are bravely sharing their data in order to keep research momentum moving forward. Here is our agenda for the day. This can also be found on our website. There's a conference tab, 2020 conference tab, so you should have all received it in your inboxes, but you can also find it on our website if you need it, and I'll pull it up at various times throughout the day today. I also want to thank our funders. Today is made possible by the NIH, Citizens United for Research in Epilepsy, or CURE, Pfizer, Zogenix, the American Epilepsy Society, and the Chan Zuckerberg Initiative Rare as One project. We will host an in-person meeting as well with these grant funds once the health of the world improves, but we do want to thank our sponsors and our grants for sticking with us through this unparalleled situation. I don't know why that picture doesn't load when I go into presentation mode, but there's supposed to be a very cute picture of my husband as a kid where it says my husband, but I don't know, maybe Emily can figure that out for next time. I tried it this morning and it looked like it worked. But okay, I'm going to start with a story about my family. So I was a really lucky kid. I'm one of 7 kids in a crazy, fun, blended family. My husband had an equally blessed childhood. He's one of 4 kids. We have no significant history of any major childhood illnesses in our family tree. My husband, no, these pictures aren't loading either. I'm going to escape from presentation view just so that you can see some of the pictures, and then hopefully it'll work in a minute or two. So my husband and I went to high school together, we went to college together, and when we realized that we couldn't seem to escape each other, we just decided to get married. We moved to England for graduate school. Life was pretty darn perfect, and after being married for a couple of years, we decided it was time for a baby. 40 weeks into an uneventful pregnancy, I was induced, and on December 22nd, 2003, my daughter was born. That's the same year that the Human Genome Project was completed. Our daughter Tessa seemed to be perfectly healthy, but we couldn't get Tessa to eat, and she turned really blue during her first bath. Go back into presentation view. On Christmas Eve, a doctor walked into my hospital room. He told me Tessa was having fits and that she had most likely had a stroke. We would know more after an MRI. I had no idea what a fit was. It turns out it's the British word for seizures. I was definitely in shock. I remember delivering the news to my husband, and my big, strong husband dropped to his knees and wept. We were 23 years old. After a couple of weeks, we were able to control Tessa's seizures with phenobarbital and phenytoin. Her MRI was normal, and as the months went on, she looked like a healthy little 6-month-old. She received her second misdiagnosis, benign idiopathic neonatal seizures. For the non-neurologists listening, this basically meant that while doctors didn't understand why she had had some seizures, they thought she was going to be just fine. And per our doctor's instructions, we weaned Tessa off her seizure medications. On the day of what was supposed to be her last dose of medication, she had a seizure. She would spend the next 15 years seizing uncontrollably. Tessa had dozens of hospital stays under her belt by the time she entered preschool. We knew our ambulance crews by name. Tessa tried dozens of medications in different combinations to little effect. We traveled across the country to see the best neurologists. We attacked the seizures logically. We tried standard anti-epileptic medications. We tried steroids and later IVIG in case it was an autoimmune problem. We tried pyridoxine and other supplements in case it was a metabolic problem. We had more MRIs and PET scans and EEGs to see if she was a surgical candidate. We implanted a vagal nerve stimulator and suffered through the ketogenic diet several times. We had every gene test available. We sought out researchers who could do exome and genome sequencing, which was not yet available clinically. Tessa's diagnosis shifted to catastrophic epilepsy. You can see here she was having up to 53 seizures per hour. We weren't sure she would survive until kindergarten. We still could not find an underlying cause for Tessa's seizures. The one thing that we took solace in was that none of the doctors we saw thought that Tessa had an inherited genetic condition. We were told to be fruitful and multiply, and we complied. Oh, we're losing the pictures again. Hold on, there we go. There's my cute family. Lily and Maggie were born uneventfully. They're wonderfully healthy and normal. In 2012, we received news that Tessa had an ATP1A3 mutation. This is the genetic marker for a disorder called alternating hemiplegia of childhood. My husband and I were tested. We were both negative. AHC is almost always a de novo mutation, which means it is not inherited. We celebrated, and a year later, we decided to have another baby. When I was 7 months pregnant, we found out that an error had been made in a lab. Tessa's sample had been switched with another child's. Tessa did not have alternating hemiplegia of childhood. We were back at square one, but we were still hopeful that our fourth child would be healthy. On August 26, 2013, I gave birth to a seemingly healthy baby boy named Colton. My husband and I knew our family was complete, and we were confident that we were the luckiest people on the planet. At around 2 in the morning, Colton started having trouble feeding. He started looking blue. I remember calling in the nurse and telling her I suspected Colton was having seizures. Tessa's neurologist, Dr. Brenda Porter, transferred him to the NICU for observation. Colton was indeed having seizures, lots of them. I went from dreaming of future college graduation and my future grandchildren to knowing that my son would likely never talk or live independently, just like his big sister. Dr. Porter put Colton on the medications that had been the most successful for my daughter. It took us 4 years to find out that a medication called Diamox helped Tessa. Dr. Porter started Colton on Diamox when he was 3 days old. Whereas Tessa was in and out of the hospital for years, Colton came home from the hospital at 2 weeks old, and he has remained amazingly stable. We immediately reached out to every researcher and geneticist that Tessa had ever seen. We sent samples of Colton's blood to the NIH Undiagnosed Diseases Program, to Baylor, even to the doctor who had misdiagnosed Tessa with alternating hemiplegia of childhood. None of them could find a genetic marker. When Colton was 3 months old, a friend introduced me to Dr. Matthew Bainbridge, who you'll meet in a little bit. He was a genetics researcher at Baylor at the time. We talked for quite a while about the kids and our family history, and a few months later, I got a call back from Matthew. He said, "I think I found the gene, and I think there's something to do about it." Matthew had found compound heterozygous SLC13A5 mutations in Tessa and Colton. This genetic marker suggested that Tessa had a citrate transporter disorder. Dr. Porter quickly tried Tessa on potassium citrate to no effect. We tried various other TCA cycle supplements. Matthew and Brenda reached out to a drug company that was developing a medication called triheptanoin. An agonizing year later, we had FDA, hospital, and drug company approval for triheptanoin. We flew my kids to Baylor to start the miracle oil. My kids gagged it down for months, but no miracles occurred. We started hearing about more and more families. Sorry, there's even more of them, I swear, there they all are. We started hearing about more and more children diagnosed with SLC13A5 mutations. They all had the same symptoms: difficult to control epilepsy beginning shortly after birth for no apparent reason. So how is Colton doing? Did he benefit from diagnosis? I wish I could say that Colton is perfectly fine, but he is not. Although we have control of the seizures, he is now 6 years old with minimal language, and he just started walking. But I do feel confident that he benefited from having a big sister who had spent a decade trying different treatment options. Having an early and accurate genetic diagnosis is like giving every child a big sister. It helps parents with family planning. It lets doctors know they are dealing with a serious epilepsy, and it allows for targeted research that will someday lead to better treatment options. After our failed attempt with triheptanoin, we took a step back and tried to get organized. Because I'm better at doing something than at doing nothing, we formed TESS Research Foundation. We have a volunteer board of directors, and a largely volunteer staff. Ooh, pictures. There's our cute staff. We also assembled the dream team of volunteer scientific advisory board members. They help us figure out where the gaps in research are and review research grant applications. We've hosted productive research roundtables, including this one. I hope this one's productive. And we've funded some really solid research. Many of the speakers you will hear today are TESS grantees. I encourage you to check out our website, tessresearch.org. Our website contains a list of pathogenic mutations, a link to our patient registry, grant cycle information, disease fact sheets, and so much more. If there is something you would like us to add to our website, please let us know. We would also be happy to write letters of support for grants from other funding sources. As Tessa and Colton's mom, I have seen hundreds of thousands of seizures. I hope this is a claim that fewer moms can make 5 years from now. We have a long way to go, but I can see the progress even in my own house. My daughter is 9 months seizure-free. I didn't think seizure freedom was even a possibility for her at this point. Dr. Brenda Porter, who you will hear speak next, continues to move mountains for our SLC13A5 children. And this is the part where you all come in. This research roundtable includes stakeholders from many different backgrounds. This disorder has an interesting set of symptoms, including seizures, tooth abnormalities, and a distinct movement disorder. As a result, today we bring together basic scientists, clinicians, industry representatives from the fields of genetics, transporters, neurology, metabolics, diabetes, movement disorders, dentistry, and gene therapy. We have experiments in mouse models, fly models, zebrafish, patient-derived iPSCs, organoids, and more. We are exploring both symptomatic relief and disease-modifying treatments with seizure medications and repurposed or off-label drugs. The second half of this conference will have a focus on gene therapy, and we have quite a few attendees from the gene therapy program at UT Southwestern Medical Center joining us today. We also have several families affected by SLC13A5 deficiency on the call today. On behalf of these families and my own, I want to thank you for breaking down silos, collaborating, and working towards a healthier future. Our hope is in your hands. And with that, I will stop sharing and hand it over to Brenda Porter.